Right now, buried beneath your feet, there is a hot dog that was thrown away before you were born. It still looks like a hot dog. The bun is intact. The mustard is recognizable. And if you could dig it down and unwrap it, you would swear someone tossed it out last Tuesday. That hot dog has been sitting in a landfill for over 40 years, and it has barely decomposed. And here's the thing. Almost everything you threw away this morning is about to join it in a state of near-permanent suspension. We think garbage disappears. We think it breaks down. We think the earth just sort of absorbs it and moves on. But what actually happens inside a landfill is so much stranger, so much slower, and so much more consequential than almost anyone realizes. So today, we're going to dig into the science of what really happens to your trash after the garbage truck drives away. And I promise you, by the end of this, you will never look at your bin the same way again. It's a psychological phenomenon that waste researchers sometimes call out of sight, out of mind disposal. The moment your trash bag hits the bottom of that truck and gets compacted, your brain files it under dealt with, problem solved, gone. But gone is doing a lot of heavy lifting in that sentence because your garbage hasn't gone anywhere. It has simply moved. And the place it moved to is essentially a massive, engineered time capsule that is specifically designed to prevent the very thing you assume is happening: decomposition. See, most people picture a landfill as a big open pit where garbage slowly rots back into soil. That image is about 50 years out of date. Modern landfills, technically called sanitary landfills, are constructed to be the exact opposite of composting environments. They are sealed, compacted, and entombed. The bottom is lined with thick layers of clay and high-density polyethylene plastic to prevent anything from leaking into groundwater. Each day's deposit of waste gets covered with a layer of soil or synthetic material. And once a section is full, it gets capped with another impermeable barrier on top. What you end up with is not a decomposition site. It is a dry tomb. And tombs, as we know, are very good at preserving things. The man who proved this was an archaeologist named William Rathje. Starting in 1987, Rathje led something called the Tucson Garbage Project, and later expanded it into full-scale landfill excavations across North America. His team drilled deep boreholes into landfills and pulled up core samples of garbage the same way geologists pull up core samples of rock. What they found stunned the scientific community. Newspapers from the 1960s came up still readable. You could see the headlines, make out the photographs, even read the classifieds. Heads of lettuce thrown away decades earlier were brown and flattened, but still identifiable as lettuce, their cellular structure largely intact. T-bone steaks from the 1970s still had meat on the bone. Rathje's team found hot dogs, as I mentioned, that had barely changed in over 40 years. The crucial discovery was this: the assumption that organic waste simply biodegrades in landfills is fundamentally wrong. The conditions inside a sealed landfill are so oxygen-deprived, so compressed, and so dry that biological activity slows to a crawl. Bacteria that break down organic matter need moisture, air, and space. A landfill gives them almost none of these things. And here is a detail that rarely gets discussed. Rathje's excavations revealed that the single largest category of material by volume in American landfills was not plastic. It was not food waste. It was paper. Construction and demolition debris and paper products together accounted for a staggering proportion of landfill volume, and because of the anaerobic conditions, that paper was sitting there virtually unchanged. The phone books, the newspapers, the packaging, all of it frozen in time. Now, to say nothing decomposes would be an overstatement. Some decomposition does occur, and when it does, it produces something that most people have never heard of in this context: landfill gas. Here's the chemistry. In the early stages after burial, whatever small amount of oxygen is trapped in the waste gets consumed by aerobic bacteria. This phase is short, usually lasting only a few weeks. Once the oxygen is gone, a different class of microorganisms takes over: anaerobic bacteria, organisms that thrive without oxygen. These bacteria begin breaking down organic material through a process called methanogenesis, and the byproduct is a gas mixture that is roughly 50% methane and 50% carbon dioxide, with trace amounts of hydrogen sulfide and other volatile organic compounds. This is where it gets alarming. Methane is a greenhouse gas with a warming potential approximately 80 times greater than carbon dioxide over a 20-year period. Landfills are the third largest source of human-related methane emissions in the United States. Globally, they account for roughly 11% of all methane released into the atmosphere. And here is a piece of research that deserves far more attention than it gets. A 2022 satellite study, using instruments on the International Space Station, identified dozens of super-emitter landfills around the world that were releasing methane plumes far larger than anyone had estimated from ground-level measurements. Some individual landfills were emitting methane at rates equivalent to the output of small industrial facilities. The ground-level monitoring systems that regulators rely on were systematically underestimating actual emissions, sometimes by a factor of 3 or more. But the gas is only half the chemical story. The other half is leachate. As small amounts of rainwater percolate through the waste mass despite the engineered barriers, it picks up a cocktail of dissolved chemicals, heavy metals like lead and mercury, organic pollutants, ammonia, and in older landfills, substances from products that were legal to dispose of decades ago but would be classified as hazardous waste today. Modern landfills collect this leachate through drainage systems and send it to treatment facilities. But older landfills, and there are thousands of them, many now closed and sitting under parks, housing developments, and shopping centers, those were built before these collection systems were standard. Their leachate has been quietly migrating into surrounding soil and water for decades. So let's talk specifics. How long does your trash actually persist? The numbers are genuinely difficult to process. An apple core, which you would think is about as biodegradable as something can get, takes roughly 2 months to decompose in a proper composting environment with air, moisture, and microbial activity. In a landfill, that same apple core can last decades because the conditions that enable composting simply do not exist at depth. A disposable diaper takes an estimated 500 years. A plastic bottle somewhere between 400 and 1,000 years, depending on the type of polymer. An aluminum can persists for 80 to 200 years. Glass is essentially permanent. It does not biodegrade at all, though it is chemically inert, meaning it just sits there without releasing harmful substances. But here is where the research gets genuinely unsettling. Those timelines you see quoted everywhere, the plastic takes 500 years figures, are largely theoretical. No one has actually watched a plastic bottle decompose in a landfill over 500 years. Those estimates are based on accelerated degradation studies in laboratory conditions and then extrapolated forward. The actual time frame in a sealed anaerobic landfill could be significantly longer. Some polymer chemists have suggested that in the absence of UV radiation, which is the primary driver of plastic degradation, certain plastics in landfill conditions could persist for thousands of years. We genuinely do not know because the materials have not existed long enough for us to observe their full life cycle. Here is where I want to take this somewhere that most videos on this topic never go. There is a growing body of research around what engineers call landfill instability over generational timescales. The engineered liners at the bottom of modern landfills, the ones that are supposed to prevent contamination for eternity, have a projected functional lifespan of somewhere between 30 and 50 years. Some estimates are more generous, pushing that to 100 years. But the waste they are containing will be hazardous for centuries or millennia. This means we are building containment systems that will fail long before their contents become safe. And when those liners eventually crack, degrade, or are punctured by settling and subsidence within the waste mass itself, the leachate that has been accumulating for decades will begin migrating into groundwater. A 2021 study published in the journal Nature Sustainability modeled this exact scenario across thousands of landfill sites and concluded that the long-term contamination risk from aging landfill infrastructure represents one of the most significant and least discussed environmental liabilities of the 21st century. We are essentially deferring a contamination event to future generations and hoping that someone, someday, will figure out how to deal with it. There is also the emerging issue of what researchers call landfill mining, the concept of going back into old, closed landfills to extract valuable materials. Early pilot projects in Belgium, Austria, and India have shown that old landfills contain recoverable metals, plastics, and even combustible materials that could be used for energy generation. but the economics are brutal. Excavation is expensive, the materials are contaminated and mixed, and the safety risks of disturbing decades-old waste, including exposure to unknown chemicals and pockets of trapped methane, make large-scale landfill mining a logistical nightmare. Still, as virgin resources become scarcer and the land occupied by closed landfills becomes more valuable, this is a field that is attracting serious investment and research attention. So what does all of this mean for you personally, standing in your kitchen, holding a banana peel over the trash can? It means that the concept of throwing something away is a fiction. There is no away. There is only a place, a specific engineered place, where your waste will sit in the dark, largely unchanged, for longer than your family line will probably exist. Every sandwich wrapper, every broken toy, every piece of junk mail is being added to a growing archive of human consumption that will outlast our buildings, our institutions, and possibly our civilization. The average American generates about 4.5 pounds of waste per day. Over a lifetime, that is roughly 64 tons of material per person. Multiply that across 330 million people, and the scale becomes almost incomprehensible. The United States alone has over 2,000 active landfills and tens of thousands of closed ones. Globally, we produce over 2 billion tons of municipal solid waste per year, and that number is projected to increase by 70% by 2050. I am not telling you this to make you feel guilty. Guilt is not a useful engineering solution. What I am telling you is that the system we have built for managing waste, a system based on burial and forgetting, is a temporary solution that we have been treating as a permanent one. And the science is now clear that the bill for that assumption is coming due. The landfills we are filling today will be the contamination sites of tomorrow. The methane they emit is accelerating climate change right now, and the materials we are burying will be sitting there perfectly preserved long after every person watching this video is gone. The hot dog is still down there, and it is not going anywhere. Neither is anything else. If this changed the way you think about waste, hit subscribe. I will see you in the next one.